Dear friends, in this video we are going to discuss about the important renewable energy sources, namely hydroelectric power plant. In India, in many places we are coming across this type of hydroelectric power plant. As I have mentioned in the previous video, this was the first power plant installed or commissioned in our country during the independence, before independence, with a little amount of power generation in kilowatts. Everyone knows as long as world is there, as long as globe is there, water will be there, water storage will be there, dams will be there. As long as water is available in the dam, we could easily convert that potential energy stored in the dam into kinetic energy, and it will be converted into mechanical, thereby electrical. That is the system. So this interesting area of power plant, that is hydroelectric power plant, which is producing zero emission, whereas in the previous videos, that is power plants related with coal based or gas turbine or diesel power plant or nuclear power plant are producing large amount of unwanted pollutant emissions. But the hydroelectric power plant, we are not going to have any pollution or emission coming out from this type of power plant, since we are not going to burn anything here. No burning is taking place. In coal based, we have burned the coal. Diesel, it has undergone combustion. Gas turbine, undergone combustion. Whereas nuclear, it is the burning of nucleus fuel, that is uranium 235. Whereas in the renewable energy source, hydroelectric power plant, though no burning, no combustion is taking place. That is a major advantage. And construction wise, it may be taking longer period. It may cover larger area, but once you install, it will run for 100 or 150 years without any much maintenance work. Everything is requiring maintenance, but it doesn't require more of maintenance work. So if you talk about the hydroelectric power plant, where we can commission the hydroelectric power plant, where we have dams, there only we could construct the hydroelectric power plant. The major source is water. Water storage is a very, very important aspect in the case of hydroelectric power plant. We know that available waterhead, that is nothing but the potential energy. Potential energy is nothing but virtue of its height. Energy possessed by virtue of its height. That is rho GH. This potential energy is going to get converted into kinetic energy. That is, kinetic energy is nothing but the energy possessed by virtue of its motion or which of the speed of mv square. These two energy conversions are going to take place in hydroelectric power plant. The another point we would consider is accessibility to the site. We have to transmit the power generated from the hydroelectric power plant to the residential area or to the industrial area. That the transmission also we have to consider. If it is very long, that may not be feasible. We have to spend a lot of money on transferring our transmission. The transmission loss also will occur if you transfer the electricity from one place to another place through the wires for a longer distance. Some 20 to 30% of the energy generated will be wasted. That is called a transmission loss. So to avoid that, the people will choose nearby area. That is called accessibility of the site. And reaching the place is also important, since we have to do the maintenance work. We have to take care of all the things, all the components, all the structures available at the site. The essential elements of hydroelectric power plant: the catchment area, that is where the water is stored, reservoir, dam and intake house, inlet waterway, power house, tail race or outlet waterway, surge tank, penstock and draft tube. These are the major elements of hydroelectric power plant. We know that catchment area, reservoir, dams, all those things, inlet waterways, powerhouse, all those things we know. The tide race, it may be new term. It is for the passage of discharging the water leaving the hydraulic turbines into the river, or in certain cases the water for the tide race can be pumped back into the original reservoir. That is called pumped storage power plant. That also we will discuss. So tide race is the passage for discharging the water leaving the turbines after doing the work from the hydraulic turbines. Mostly we are using reaction turbines, the Francis type of turbines. After rotating the turbine blades, the water will be leaving at the tail race level. That has to be discharged to the river, or it may be pumped back to the original reservoir. Another important component or element in power plant is the surge tank. The surge tank is placed in between the penstock. It may be of length 1 kilometer length. The penstock is nothing but a concrete pipe to carry the water from dam to turbine. It may be of having around 1.5 to 2 meter diameter of concrete steel structured tube. If the pressure rises in the tube due to sudden breakdown in the tail reservoir turbines or due to some other reason, there is a possibility of bursting of the tube. That bursting of the tube due to the pressure developed inside the penstock is termed as water hammer. So we have to release the pressure in the penstock if it is going beyond the limit. For that we will provide a surge tank, a water tank structure will be provided in the penstock. The excess pressure, the water will be let into the surge tank so that the pressure in the penstock will be reduced. The draft tube, it is related with the tail race, that is the water will be discharged from the tail race to the river by means of draft tube. So these are some important components or elements of hydroelectric power plant. This is a simple layout of hydroelectric power plant. It is not a complicated one. Very simple layout. Catchment area, dam. From the dam, the water is pumped. So this is the catchment area. This is a dam. For example, it is Murto Dam. Here we have the gate wall. When the gate wall is opened, the water will be released through this gate wall at high pressure. So it will be water will be passing through this penstock. Already I have told that the penstock is a concrete huge tube which carries the water from the dam to the turbine end. So in the penstock, in between the penstock, we have the surge tank to avoid the water hammer, and here we have the inlet valve, and here we have the nozzle. The high energy water, high potential energy of the water will be converted into mechanical energy by means of kinetic energy. So through the nozzle at high velocity, the water will be impinging on the turbine blades, so that the turbine blades will rotating. The turbine is connected to the turbine shaft, so the shaft will also rotate and will be generating the power. This is a draft tube. This is a tail race level draft tube. This is a tail race. The draft tube is nothing but a passage connected between turbine outlet and the river. This is the generator room, control room, transmission, all those things we are very familiar. This is about hydroelectric power plant. The surge tank, the structure of surge tank, you can look at this. The purpose of surge tank is to reduce the water hammer, to reduce the possibility of bursting of the penstock. So in between the penstock, we have constructed this surge tank. This is a tunnel supply pipeline. This is a water storage in the surge tank. When the load varies upon the load, the water level in the surge tank will be very increased load, normal load, static load, and decreased load. This is another type of power plant, as I mentioned here. When the power demand is very less, no power is required. During the winter season, ACs will not be operated, so the power demand will be less. During that time, the water available in the territories will be pumped back to the original reservoir by utilizing the motor and pump. The excess electricity is already available. Using that excess electricity, the water will be pumped back to the original reservoir. Whenever demand is more, the water will be utilized for power generation. So this is called the power pumped storage power plant. This is a diagram for pumped storage power plant. This is a pond tail raise level. By using the motor and a generator or motor pump, the water in the pond tail race will be pumped back to the original reservoir. That's why it's called pumped storage power plant. This is a Pelton wheel, as we have discussed the fluid mechanics, the spare and nozzle, and this is a reaction turbine. This is a Francis turbine. So with this, we will conclude this video. Thank you for watching.